Well, it's 2:01, so in the interest of time, maybe I'll start with the introduction, and it'll take a couple minutes, and then we can get into the actual lecture. So welcome, everyone. Thank you for joining us. My name is Stephen Gallo. On behalf of everyone here at the American Institute of Biological Sciences, I want to thank you for joining us. AIBS is a national scientific organization dedicated to advancing biology for the benefit of science and society. One way that we do this is by providing decision makers with timely and vetted information, and we do this independently and in partnership with our members and business partners. So today's presentation and discussion is part of an ongoing webinar series called Leadership in Biology. These programs bring the scientific community together to discuss cutting-edge issues that influence the conduct and advancement of scientific research and education. It's part of a broader initiative that not only includes evaluating merit review, but also recently we had one about Zika virus and using gene drives. So there's a wide variety of topic areas. These and other AIBS programs are made possible by the support of members and donors. And if you're not an AIBS individual member, I encourage you to consider joining today. In addition to these informative programs, you'll also receive a subscription to our journal, Bioscience, and the opportunity to participate in other programs, particularly our science policy and communication training initiatives. You can learn more about AIBS, future programs in the Leadership in Biology webinar series, or make tax-deductible donations or even join AIBS via our website at www.aibs.org. So again, my name is Stephen Gallo. I'm the Technical Operations Manager at the Scientific Peer Advisory and Review Services Division of AIBS, or lovingly referred to as SPARS. So SPARS is well, AIBS as a whole has conducted peer review for a wide variety of funding agencies and research organizations for over 50 years. And we're committed not only to analyzing and sharing a lot of the results of our own analyses of these peer reviews, but also disseminating and promoting discussion of others' results, because there's currently a very small body of research concerning the peer review process and relatively poor communication. There aren't very many conferences that talk about this particular topic, and yet there's a wide diversity in the way that people conduct peer review. Through this effort, we're trying to hoping to grow the community discussion to promote the integrity of the review process. So in terms of SPARS, please visit our website, which is an additional website, SPARS, spars.aibs.org, or join us on Twitter at AIBS_SPARS for peer review news, lists of publications on the science of peer review, and archived and upcoming webinars and associated kinds of materials. And we're actually fairly active on that line, so please join that. So at this point, I'd like to introduce our speaker today, who's Dr. Daniel Acuna, research associate at the Rehabilitation Institute of Chicago and research affiliate in the Department of Biomedical Engineering at Northwestern University. We've just recently found out that he'll be joining the School of Information Studies at Syracuse University as an assistant professor this coming fall, so congratulations to him. His research interests have focused largely on studying large data sets using machine learning techniques to better understand scientific publication, funding, and teaching activities. And today he'll be largely speaking about content-based review manuscript assignment. So to actually assign reviewers to specific, in this case, manuscripts submitted to a journal, and Bayesian article scoring to correct for biases in peer review. And I think that's all I have for the introduction. So Dr. Acuna, would you like to take it away?
Sure. Well, let me share the screen on the presentation.
Oh, sorry. While you're doing that, one more thing I should note. So this webinar will be separated into kind of two segments. The first segment will be Dr. Acuna's presentation, and then we'll have a question and answer period. You can ask questions through this little tab at the bottom of your screen called Q&A, where you can actually chat them. I'll be sorting through them and asking Dr. Acuna them kind of in the order that they come in. But feel free to add, there'll be time at the end for that. So thanks.
Okay, is it working? Does it show up?
Yep, you're good.
Good. Okay. Well, thank you very much for the invitation from IBS, from the Institute. It's very exciting to be here. I'm very excited to be talking about something that, as Stephen said, is kind of being neglected. The idea that we can use data and machine learning to try to understand the expertise of reviewers and the topics that manuscripts are presenting, and then try to match the two together using a more, if you will, objective content-based strategy. Well, something that that has always been interesting for me is how humans are biased to when they make decisions. Okay, so when I was studying computer science, let's say, I was very intrigued by how people make decisions when there is uncertainty about multiple options. And we did this experiment where we will show people different options that have different, let's say, reward uncertainties. And what was striking is that people are actually very good at making those decisions. So the overall conclusion of that field is that people are near optimal at combining uncertain sources of information. Now, what happened, unfortunately, is that when we move into more real-based problems, and I'm sure many of you have seen the dress, which this picture went viral last year. So unfortunately, I cannot interact with the audience much, but think about yourself and how your friends saw this picture, right? So this picture is a dress, and the question was simply, what color is this dress, right? So one set of people said that this dress was black and blue, whereas another group of people said that this dress was golden and white. Okay, so this generated a wide variety of discussion in the internet, and people from all walks of life started to try to give their answer. There are multiple answers to why this is happening. But one important thing, or one particular point, is that when people are trying to answer this question, they bring their prior experiences, right? So some people, let's say, see this information, this picture, and they assume that this picture was taken outside. So they assume that the sunlight is hitting the dress, and they know that the sun changes color when it hits clothing, and therefore when they respond to the question, what color is this dress, they discount the changes that the sunlight is making to the dress. Well, another group of people made a different assertion. They thought that the dress was inside of a building, and therefore was being hit by an artificial light, let's say a fluorescent light. And therefore they thought that because of that, the dress was being affected in a different way, and they would discount the effect of the fluorescent light on the dress in a different way. Therefore, you have these two groups of people. Now, what's interesting is that at the end, everybody was looking at the same evidence, right? And we can link this to peer review. Everybody's looking at the same manuscript, but because they're bringing their experiences from outside, then they make different decisions. And those experiences might be beneficial for them making decisions. But unfortunately, many times, those prior experiences bring a lot of biases into the peer review process. Now, we've witnessed over the last couple of years many cases of these kind of biases in science, in particular in peer review. So we have seen many cases of retractions, many cases of the results being presented in papers not being as strong as they should be, and therefore not replicating with other scientists that are trying to apply the same methods described in the paper. And finally, we have scientists trying to just flat out trying to game the system, in this case, groups of scientists trying to be the reviewers of their own paper. So my research is about trying to understand what are the biases that are present in peer review and how we can create machine learning tools, artificial intelligence tools that can enhance the decision making. Now, on top of all of this, scientists really have little time to spend on science, or what we think is scientific. So here I'm showing you a graph of the time that a typical scientist spend in a week on different tasks. So let's say here, class preparation, emailing, meetings, instruction, all of that, as you can see, takes a sizable chunk of the time in a week. Whereas the things that we think are scientific, like manuscript writing, peer review, primary research, literature review, all of those things are comparatively much less stress, much less done in a typical week. So we have a compound problem here. We have editors and program officers making decisions about peer review, decisions that are affected by just how humans are, the biases for prior experiences. And also, we have little time to do those tasks. And therefore, we're asking a lot, and we are asking science to depend a lot on humans to make those decisions. So I will talk about two projects that are really part of the same idea, which is essentially trying to improve the peer review process by informing the decision of program officers, of editors, when they're choosing the correct reviewer. The first part that I will talk about is review matching. Okay? So peer review is this essential component of science. And again, it's surprising to me that many of the most important things on science, unfortunately, are very labor intensive and therefore very prone to errors. So if you think about it, peer review, checking the quality of the evidence of a paper, checking, let's say, p-values, looking for fraud or looking for plagiarism in text, looking for the relevant literature. All those things are very, very labor intensive and therefore very prone to biases. And the peer review is one of the most important things in science. It helps an idea to be checked first for correctness, then for importance, for significance. And then we let that idea then go out to the public and be seen for other scientists. Okay? Okay, so let's be a little more concrete. Let's imagine we are at a conference. We are a program chair at a conference, and we get a set of papers, and we have a set of potential reviewers that could review these papers. Now, ideally, we would like to, well, there are many, many different criteria, but ideally, we would like reviewers to review papers that are in their expertise. We want expert assessment of the idea contained in a paper, right, in a manuscript. So think about the tasks that a program officer and a program chair will have. They need to first understand the topic of the manuscript. Some of them are expert, they're professional scientists, but some of them are just expert editors, and they may not know all the literature, or nobody knows all the literature, so because the papers are very specific. So they first need to understand the topic of the article. Then they need to understand the expertise of the reviewers to make an invitation to review a paper. In a sense, we also want to avoid all of these conflicts of interest that happen when reviewers are saying, I think I would like to review this paper. Right? Sometimes we trust reviewers telling us what they would like to review. But liking to review something doesn't necessarily mean that they are expert on the topic. Many times, and that happens to myself, I like to review a paper because I know a little bit, but also I would like to learn what the state of the art of that particular topic and learn while I review. The other thing that happens sometimes is that authors suggest reviewers that could review the paper or that shouldn't review the paper. But editors sometimes don't realize or don't take into account the effects that might happen and the biases that could appear because of that practice. So Now I'm going to take this and be very concrete about how I build software tools and approaches to make the assignment quantifiable and done by algorithms. Okay, so I will apply like one of the simplest techniques to analyze the submissions to Manuscript. So here's the preprocessing workflow of the Manuscript. So let's say I have a list of abstracts submitted to a journal. I do some simple pre-processing where I just take the words that are contained in the manuscript. So I don't care about ordering and things like that. I may care about like pairs of words. Let's say decision making is not the same as decision uncertainty, let's say, or things like that. So I care about the words themselves alone and also pairs of words or bigrams as they're called. Then I want to discount things based on how much they're used across all documents. So for example, I don't want to take the word science as representing an abstract because science is really used across all the papers. So I want to take the words that are really indicative or special about a particular document. And then I want to take that huge list of words that are present in a document and do dimensionality reduction. Essentially capture in one long vector, but not all the words, in one long vector, the topics of an abstract. So I have taken text to a vector. Now, we can take this idea and apply it to peer review. So let's say we have, again, the papers. We have mapped all the papers into a vector, let's say a d-dimensional vector. And also we can take the papers that the reviewers have written. Okay? Not the papers that they would like to review, but actually the papers that they are expert on, the papers that they have published. And we can take the vector of those documents, and we could take the average. Okay, so at the end we will have the topics of the papers and the topics of the reviewers, and we could compute a distance function, a distance between these two sets. So we can compute a matrix that would represent the distance of a particular paper to a particular reviewer. Now, this distance here is where you can start playing with different things that we think are important. So, for example, the simplest approach will be to say, okay, this will just be the cosine distance between these two vectors. So essentially, we will be looking for papers that are very close in topic space. Right? Another thing that you could do is to say, okay, the reviewer topic space should really be more towards the latest paper that this reviewer has had. Like, how many of you have received invitations to review a paper of ideas that you wrote like 10 years ago, right? So in a way, we could compute an average of the topic of a reviewer, but we could discount things that passed a very long time ago. So, and that way, the distance function will be more towards the papers that are relatively recent. And lastly, we can take this matrix of distances into a linear programming approach, where we can say, okay, we want to minimize the global distance, let's say for a conference, the global distance of reviewers to papers, while we are subject to certain constraints. And typical constraints are, okay, we want each paper to be reviewed by three people exactly. And we want each reviewer to not review more than 20 papers, let's say. Okay? So, fortunately, this problem is actually not that computationally hard. It just boils down to a linear programming problem. Okay, so let me show you now how this works and how we have made this available for everybody to use. So a lot of things that I presented here, I make concrete in software that I share on GitHub and that I try to put websites so that people can try them. So this website is specifically designed for peer review, and it's called peerreview.scienceofscience.org. You can go there and do these two things that I will talk about peer review. First is making assignment, and then I will talk about the scoring part. So in making assignments, you go here, and you need 3 files. Okay? You need one file. Here I have example files. You need one file that says, okay, this is the list of people that I have in the program. Okay, so this would be the list of authors and the reviewers for a conference. Okay? You just need an ID and the full name. And these just happen to be the people in my lab.
Dr. Acuna, all we're seeing is the slide, the Google Slides, Google Drive. I think you need to, I think you just shared that.
Okay.
Yeah.
Sorry. What about now?
There you go.
Okay, sorry about that. So again, this is the website I was talking about, pr.scienceofscience.org. You go here and you go to make assignment, and I was saying that you need 3 files to produce this assignment. The first one that I was showing was the list of people. It would include the authors and reviewers, and here I just happen to put all the members of my lab. And the other file is, oh, you're not seeing that, sorry. Well, anyways, you need a can I somehow share all the screen?
So if you go to the bottom where it share screen, if you click on that, there's an option to share your entire screen, not just a specific program.
Okay. Well, let me just keep going with this because, so you're seeing now this. This is the full screen, right?
Yes. So we're seeing right now the reviewer, assignment, uploader, with the 4 tabs and make an assignment. Okay, good. So and here you see the Excel, right? Correct. Okay, good. So this is the first file that was saying the reviewers and authors. The other file is the article list. So you have the paper, you give an ID, the abstract, and the authors of the paper. And the last file is the reviewer list, where you will say, okay, these people are reviewers. In our case, in this example, I'm putting everybody as reviewer. And then these are example abstract of this particular reviewer. Now, again, this is only based on abstracts. So you could specialize these and put other stuff like let's say, geographical location. Like sometimes program officers are looking for diversity. So you want to have many people from different geographical locations. They might look for different types of institutions. So you can put those things into the model. But this is only for now about the abstract. So let me put this information. I'll put the people list. Then I will put the article list here and the reviewer list. And you can add additional conflict of interest, right? Things that are not really available in the co-authorship network. And you decide how many reviews each of the articles you have. In this case, I'm saying, okay, exactly 3 reviews, each of them. And then you decide how many reviews each of the reviewers should provide. So in this case, I can say, okay, 2 reviewers each and a maximum of 5. I don't want to overwhelm anybody. In conferences of 600 people where we run this, typically we don't want people to share more than 20. Sorry, to review more than 20. And then we make assignment. This it's sent to the server, and it's solved all in the server. And we give back the assignment based on the topics. And so this is me, and as you can see, I'm reviewing, well, you don't know this, but all the papers that I got assigned were not really co-authored by me, but are papers that are really interesting based on the topics that I put as a reviewer. So, okay, so I'm going to go back to the presentation. Can you see this? Is it showing? Yep, you're good.
Good. Okay, thanks. Okay, so you can make the assignment, and it's all good. Okay. Now, after you get back your reviews in a big conference, let's say, you have a problem now with scoring, right? You have, let's say, 3 reviewers giving different scores, and sometimes reviewers don't agree. And you might wonder, okay, they are not agreeing because this paper because there is a reviewer that is like too harsh in general, or there is a reviewer that is too nice in general. So the idea of this part of the research is to try to create a statistical models that will pull out those effects and remove them from the score and give you an estimation of the true score of an article. Okay? So this is what I was talking about. So sometimes you have, let's say here, we know that this is a great manuscript, let's say, and you have 3 reviewers giving the scores to this great manuscript. And sometimes you might have a Grand Prix reviewer, let's say, that just always finds everything really bad and gives very low reviews compared to the average, let's say. So this unfairly affects the greatness of these manuscripts, and it may not even get accepted because of that. And you can have the flip side, where you have a really or a bad manuscript that gets reviewed by a really nice reviewer that it finds everything great and gives really high scores no matter what. So this will again be another type of bias that might happen. Well, the problem is that in a conference, you have a situation like this. So you have a situation like this. You have a set of reviewers reviewing sets of papers, but you don't know which reviewers are grumpy, let's say, or which reviewers or which papers are great, right? But what you can do is that you can use how reviewers review different sets of paper, and you can pull out that statistical credit assignment from the scores and the way that they review each of the papers. So let me be concrete. So let's assume that all the papers are the same, right? They are the same level and they have the same average score, let's say. So what you can do is you can look at the scores that the reviewers are giving to each of the paper. So here the arrow means, let's say the black arrow means this reviewer is giving an average score to this paper. The red arrow means that this reviewer is giving a lower score, and the green arrow means that the reviewer is giving a higher score than the average. Okay? So here, let's say you have one reviewer giving a high score, another reviewer giving a low score to this paper, and another reviewer giving a high score. Okay? Well, maybe this paper then it shouldn't be at this level of the black arrow, but maybe it's like a combination of the black and red, right? But then when you start seeing how this reviewer again gives a lower score to another manuscript and doesn't agree with other reviewers that are giving an average score, then you might start wondering if, well, this reviewer is just really having a lower expectation and therefore giving lower score. And you can do the same with people that are giving, in general, high score. You can use the different sets of assignment to control for this kind of effect. And you can do the same for papers. Right? Let's say now you can say, okay, how to detect what are the best papers? Where you can say, okay, reviewers, let's assume now that the reviewers are all the same, equally not biased. And you can say, okay, if all reviewers are agreeing on how great this paper is, and these reviewers change their score for different sets of paper, then this paper is really great. If all reviewers are giving a great score to this paper, and then for a different paper, they're giving different scores that are closer to the average, then this is really a credit to the paper, not to the reviewer being nice or something like that. And you have the same idea for let's say bad papers, manuscripts. Now, the great thing about the approach that I propose is that we will use a Bayesian modeling, in which, and a Bayesian modeling just simply means a model of how we think the statistics of the world, in this case, the statistic of peer review, work. And it has assumptions, and you may agree or not may agree with those assumptions, but the cool thing is that you can change those assumptions and see how those changes affect your final outcome. So the first assumption is that, okay, great manuscripts and bad manuscripts are rare, and that on average, most papers are on the average score. And you can make the same assumption for reviews. You have really, in rare cases, you have a Grand Prix reviewer, and in really rare cases, you have very, very happy reviewers. So you can think of this as a statistical model in which you have now a distribution of the deviation of the article score from the mean of all articles, let's say in a conference. And you can take the mean from, let's say, past versions of the conference, or maybe from all science, right? So let's say NIH has a big set of the priority scores, and maybe they want to take those previous priority scores and take the mean of that. And then also you need to make an assumption about the distribution of how different articles, manuscripts, deviate from that. So in this case, for example, I'm assuming that most articles don't have any deviation, so that they're right around the mean with a very high probability. And that probability starts decaying when they have a negative deviation, when they're bad papers, and the same thing when they're good papers. So you have very rare good papers and very rare bad papers. But again, you can take propensity priority score from NIH and estimate this distribution in a much better way. The same idea now applies to reviewers. How reviewers, now you can make an assumption of how reviewers deviate from the mean score of papers for one conference, and you can again say, okay, this is how rare I think happy reviewers are or grand reviewers are. And you can make now a statistical method and a statistical model of how the score that you see when you get as a program officer or as a program chair, the scores that you get for a particular abstract and from a particular reviewer, how that gets into this final number, okay? So the assumption here is that the final number that you see is really the average score for all papers in the conference, modified by the deviation of how great this paper or how bad this paper is, and modified by what's the reviewer's central tendency, plus some noise. Okay? And you can take this model, and now in Bayesian statistics, then you can compute an estimation of the distribution of any quantity you want. So in this case, we want what's the article difference compared to the average. Let's say we take the average score of all articles, what we think is the average score of all articles, and we add the deviation of this article. And we want to estimate this distribution given all the data, given all the scores that we got from reviewers and for all the articles. Yeah. And what we want to estimate here are usually one thing, which is essentially, okay, what's the score of this article controlling for all these different effects? In this case, will be what's the expectation of this probability distribution? That will be the score estimation. Now, what's cool about the Bayesian statistics is that you can say, okay, sometimes I may have a reviewer that doesn't review a lot of papers, so I don't have a lot of information about the reviewer, and therefore that should affect the shape of the distribution. Maybe for some papers, I have a strong evidence that the paper is great. For other papers or for other reviewers, I don't have a lot of evidence. And therefore, we can compute how uncertain we are about this estimation. And I will show you that part. Is this sharing the screen? No, okay. I'll share it right now. Hope that's sharing.
Yep, you're good.
So score, this is the other part, the score. And scores, it's a really simple process. You just provide the reviewer, the paper, and the score that they gave. And in some conferences, you have a confidence. We apply this method to the computational system neuroscience conference, and the reviewers keep this confidence score. The higher, the more confident, okay? So you just provide this data file here, and it runs the Bayesian estimation. Again, this is relatively simple, so it runs fast. So here, this case, we have, for each paper, we have the mean score estimated. So let's say paper 3 here is the best according to this measure, is this paper right here. So I'm displaying here the mean score estimated of the paper and the standard deviation of that paper. And so this is a very strong paper, And I'm very certain that this is a very strong paper because I don't have a lot of uncertainty. But let's say for this paper, I think this paper is in the middle, but I have a lot of uncertainty. So this paper could be here or could be here, so I'm not sure. And then there, the program officer or the program chair should decide what to do. So I'm going to go back. Now, we apply this to a conference, and two things happen. Let me go just before I show the results. So the algorithm assigned the reviewers, and then the program chairs could say, okay, I don't think this reviewer should review this paper. So they could replace the assignment made by the algorithm. Okay? So we look at the effect of that replacement in terms of the score of the paper and in terms of the confidence. And we found two things. So here I'm showing you the effect of the reviewer score based on a bunch of features about the review. Right? And one of those features was whether the reviewer was replaced by a human. And this shows a positive effect. What it means is that when a reviewer gets replaced by a human, the reviewer that is replacing another one is usually giving a higher score than the reviewers that are reviewing the same manuscript. Essentially, humans are choosing someone who they think, well, this is one interpretation, who they think will give a higher score. The other important part of this is that the confidence of that reviewer that was replaced, that is replacing another reviewer, goes down. Okay? So you have program officers saying, this guy or girl should review this paper, but that guy or girl is giving a high score and being less confident than the peers that are reviewing the same paper. Okay, so I think I'm good on time to present this last piece, which is after you do all of this, sorry, before you do all of this, the scoring, you need to decide who you should invite, right? So you have all your suggested reviewers that the algorithm or the editor, after going through the algorithm, or the editor itself going by himself or herself, he needs to decide who to invite, right? So we want to avoid the following case: inviting someone who will say no, right? Because we will have spent a lot of time trying to find an appropriate person for a paper, and we don't want them to say no. Okay? So we have a data set from a journal that shall remain anonymous for now, because we are about to submit this to a journal, but essentially we have the full review process of this journal. And we can see what are the features that affect a reviewer to accept an invitation to review or to decline an invitation. Okay, so here I will assess the effect of these different features on the decision. So I have features related to the reviewer, like how senior or how famous, if you will, this reviewer is, the H index, number of papers, number of citations. And also have the relationship of the reviewer to the journal, like how much this reviewer has reviewed in the past, how long ago, and things like that. And finally, I have features relating the reviewer to the authors of the paper. Okay? And these are the effects that I found. So essentially, essentially what I found is that if the reviewer is very senior, let's say, he will decline to invite to review more often than if the person is less senior. But what's interesting is that if you have someone with many papers but not very senior, then they will be much more willing to say yes. The other big effect, of course, is that if this reviewer has reviewed in the past for this journal, he will be or she will be much more likely to say yes to the invitation. And finally, another thing that I think is interesting is that if you have a reviewer being more senior than the average author of the manuscript, then they are less likely to say yes. Okay, so you have those three effects. Essentially, you want someone who is not that senior, who has reviewed in the past for you, and who is not that different in seniority from the authors. Now, what's interesting is that now you can start building models for predicting this effect, or the propensity of a reviewer to accept an invitation. And we run a very simple algorithm based on logistic regression, and editors in general have a 44% chance of getting an invitation accepted. Okay? And with the algorithm, we can reach 66%. Okay? But I don't think that's, I mean, this is not really a very well-controlled experiment, because we haven't really tried this on the field. This is just based on the observation and the data that we already have. And we will hope to test this idea in the real world. But what's interesting about this, though, is that we can start framing this problem of who to invite from a decision theoretical point of view. Okay? So you can think that we have 4 possible outputs of this decision process. We have 2 that we don't like, and there is one that we really don't want to achieve, which is in the case in which we invite, the algorithm thinks that we should invite someone, but that someone declines. Okay, so this quadrant here is really bad. Also, this quadrant is relatively bad. So not inviting someone that might have said yes. Okay, so we also want to avoid this place. And these places here don't really have any cost for us, because this is just great. From a decision theoretical point of view, we can think of this quadrant here as a search cost, right? Someone we invite declines, we have to start again the process, and we have a search cost there. And if we don't invite someone that would have said yes, then we have an opportunity cost, right? And let's say with these other quadrants are great, but we don't have any cost for them. Now, what's interesting is that once you start operationalizing this cost, there is a theoretical argument for what's the best strategy that will minimize your cost based on the features of your algorithm. Okay, and that strategy is to invite someone when the probability of acceptance that your algorithm predicts exceeds this ratio right here. Let me give you a concrete example. So for this journal, the time it takes for an editor to get a manuscript, look for appropriate reviewers, invite that reviewer, and getting the response back from that reviewer is on average 21 days. Okay? So if we invite someone that says no, then we will lose 21 days of time. Okay? Now, this is a lot harder to estimate, the opportunity cost. And I put here like a very low number, because for this particular journal, it's very large. If we don't invite someone that would have said yes, maybe they will like get mad at us and they will never review again. So, but let's say just one day that we are losing, because I could look for another reviewer that would be willing to review for our journal. Okay. So using the previous formula, this means that we should invite someone only when our algorithm thinks that with 90% chance that someone will say yes. And with this decision boundary, we achieve a 99% acceptance rate. Okay? So of the people that we invite, 99% of them are accepting the invitation. Sounds great, right? Well, the problem is, of course, is that we are missing a lot of people, because we are being so stringent and we fear these quadrants so much. We are not inviting a lot of people that would have said yes. And in particular for this paper, for this journal, we are missing around 80% of the potential reviewers. But using this framework, we can start tweaking what is our threshold, right? Okay, we were around here, 95%. Maybe we will be a little bit less stringent, and we can start estimating how much of the review pool we will be losing if we move our decision threshold, right? And this decision will depend on the type of journal as well, right? So for this journal, again, that I'm analyzing, they have thousands of reviewers. So maybe they can discard 40, 60% of the potential reviewers that would have said yes, because they just want to get reviews very fast. But let's say for a more specialized journal, maybe they don't want to be so stringent and they want to invite people that might say no, but because it's so crucial to have reviewers, maybe they will invite those people anyway. And therefore they will keep a lot more of their pool of reviewers. So to sum up for this section, the best reviewer seems to be the postdoctoral researcher. That person who has many papers, usually, that is not that senior in terms of the H index. Let's say not a lot of people are citing him or her. The postdoctoral researcher usually reviews papers, so this person has reviewed for me in the past, and he's not more, they tend to be known more senior than the author, and therefore, again, they will be willing to review. And the last, if you would allow me, I would like to show one last thing, which is a website that we have that I would like to advertise, and I think will be great for everybody, which is applying the same idea of trying to understand the topics that are present in manuscripts. You can now see, okay, how can I find papers that are related to my interests? And just let me show you how it works. It's just very easy. It's just a big search bar. You go to this website, and you say, okay, I'm interested in let's say, fMRI, although that's very general, but let's just say that's interesting for me. So let's say I'm interested in fMRI with epileptic. So I say, I like that. And I don't know about the other ones, but that's interesting. And as soon as I like something, I have this menu here, recommendations. I click there, and it essentially takes that paper that I like, takes the topics, and finds things that are related, and gives me things that are related to that particular paper. So here now I have causes of epilepsy. Okay, so let me like that one. That sounds very interesting. And it starts learning more and more about things that I like. Maybe I like music with epilepsy. This sounds very interesting. And it starts liking that. And then I can click here, go to PubMed. Oh, sorry, not this one. If I click there, then I click here, I go to PubMed, I see the article, I read it, great, and I can see when it was published, things that, let's say, are relatively recently published. I can start pinning down things that are really interesting. So please, we are starting this website, and it would be great if you can try it and see how it works for you. And with that, let me see my presentation, go back to my presentation. And I would like to acknowledge the great help of a grad student here, Tite Barashikul Visud, the PI of my lab, and a bunch of organizations and funding that have made this software and these services possible. Well, thank you very much, and I'd be glad to take any questions.
Thanks very much, Daniel. That was a great presentation. Actually, we have a queue of questions already. I'm probably gonna, I have one in particular that I prepared that I thought just made me think, you know, in terms of the Bayesian correction data, you correct for consistently harsh or generous reviewers, but, you know, there's been a lot of talk about the wide variety of sources of biases that can exist, many of which depend on the characteristics of the proposal or the reviewers or the applicants. And so this biases based on those things may not necessarily be consistently harsh across a whole reviewer's scoring history, but may vary based on these types of characteristics. So are you able to incorporate those kinds of characteristics into this?
Yeah, that's a very good question. So the model, can you see the screen? So the model that I presented here is very simple. So it's like making an assumption about how the score is generated based on the article and the reviewer. And the reviewer model is simply just a random sample from a variation and distribution. But you can add here all kinds of stuff. You can say, okay, the reviewer is not just a random sample, but it has relationships with the field. Let's say in some fields, people are very critical. In other fields, people are very open to publish stuff, even though they're not finished yet. Or also stuff related to the article. I don't know, is the article citing the appropriate standard citations of the field? Is the article having the appropriate statistical test and things like that? So you can yes, add things here to this part of the model and start to estimate them separately.
I see. Okay, great, thanks. let's see. I'll just try and go in order here. The first one I have is, what data source are you using for the article metadata?
For the article metadata, so you can, I'm using the abstract. Okay, so all the assignment that is happening here is only based on the abstract. And we're working on some extensions here. I think I mentioned it, that sometimes program officers, for example, are looking for geographical location or type of institution. So they want to assemble panels that are experts and that they are diverse.
I see. Okay, let's see. So are you getting those from a particular source though, or is it something that's confidential?
Well, no. Well, you can, at least for the website, you can put whatever you want. You can put all the abstracts. So it's very user-driven. You can, let's say.
Right. I just thought in developing the model, what data? So you just made up, grab data from PubMed or whatnot, and.
Yeah. So the validation of the model, essentially, how we are trying to validate. So one thing that we're trying to validate is the matching part. We're trying to reproduce. Let's say if I'm suggesting, let's say if I learn about an abstract, then I'm trying to make decisions about my model based on how good I will suggest another abstract in terms of the topic. So essentially, I'm modeling everything in terms of how humans have put papers into categories. And for that, I use Society for Neuroscience data set of the posters that were presented here last year, 2015, in Chicago. But they're very flexible with the license, but you have to send an email and get access to that data.
Okay.
And the other, I guess, just anecdotal approach, anecdotal evidence is that we have applied this 3 years in a row, and now program officers are complaining a lot less about the assignments, and they are reassigning a lot less. Yeah.
So I have another question for the automated reviewer assignment based on abstract information. Would the program always identify a best match even if areas of research between the reviewer pool and the application are disparate? So in other words, how does this system handle mismatch, I guess?
So let's say the extreme case. If there is someone who is just not appropriate for the program, the system will try to assign the fewest possible papers to that person. If someone is like in the middle of all the topics of a conference, that's the most popular guy because everybody wants that person to review every paper because this person knows about everything. And that person essentially would max out all the allocation. So essentially the system will automatically use the constraints as a way of, let's say, removing people that are not appropriate in general and maximizing the mileage of the people that are very good for the conference.
I see. Okay. Kind of in a different, someone's asking whether this approach can be used for assigning reviewers to grant proposals. I presume that's presuming
Absolutely.
You use abstracts.
Absolutely, yeah. So I'm actually working on that, and I hope the grant is it's funded. But essentially, for grants, I mentioned this before. This approach, as it is, can be used right now for grants. So you just put, instead of manuscripts for the conference, you put all the grants for, let's say, NSF, NIH, and one side. On the other side, you put all the program officers and let's say, the abstract of the program that they run, and then you do the matching.
Nice.
But that will match only based on the collaboration. And I know that program officers are looking for different things. They're looking for that will only look for the content. But program officers are looking, again, for diversity in terms of location, in terms of types of institutions, and also in terms of how the grants relate to previous grants. So that could be something that could be put in the system. So again, here in the decision matrix, you can put all kinds of stuff. So one thing for grants, for program officers will be, okay, we want program officers and grants to match, but we want to kind of discourage reviews of grants that are very close to other grants that have been funded in the past. So essentially, you can kind of penalize those grants that essentially don't break new grounds. At least NSF, that's what they want to do. They want to do transformative research, transformative grant funding.
Innovative, yeah. Someone asked a question about incentives. Does this all change if we offer to pay reviewers a modest stipend? For example, if will even more inexperienced reviewers say yes if we give them money?
That's a very good question. I don't know. I don't have data, and I mean there are. Yeah, I don't know.
Yeah, it's a bit. Actually, a follow-up to some extent is how can we distinguish between an exceptional reviewer who really understands a proposal better than anyone else versus an exceptionally grumpy or friendly reviewer? Is it important to have discussions between reviewers to bring out a point that the exceptional reviewer may understand better than the other? So I think they're talking about the power of discussion.
Yeah,
usefulness.
Yeah, that's a very good question, but I don't really deal with that with this simple model.
Sure.
Yeah, and there are other dimensions, right? Like some reviewers, they may be equally expert, but maybe the reviews themselves that they provide much better quality. So I haven't dealt with quality in this matching. And the other thing that people ask often is like timing. Like some reviewers give these amazing book type reviews, but they take like 2 months to review, and they can be as very close in helpfulness to someone that takes like a week. So those things will be interesting to add to the model.
Absolutely. And I would say that's kind of a fundamental tenet of a lot of grant review, is the proposal discussion to try and remove some of these biases. But whether it works well or not is another.
Right. And also, let me just mention that these tools are not like trying to replace editors and trying to replace program officers. I'm just trying to enhance the decision making that they have. So I will propose, I think these guys or girls should review the papers, but you have the final decision because you know better, and you can look at things that the algorithm doesn't consider or things that are not even quantifiable yet.
Absolutely, yeah. There's some nuances to facilitating peer review that can't be necessarily captured in an algorithm. But like you say, it's maybe a tool to enhance decision making.
Exactly. Yeah.
Useful. I think I have another question regarding decisions of which reviewers to ask. If the model is strongly dependent on prior review activity, how does the model handle inclusion of new reviewers? Otherwise, wouldn't a high threshold lead to an ever-declining reviewer pool?
Yeah, that's a very, very good question. So whether someone has said before yes, it's part of the model, but if someone has never said yes, but they are very, very good and they are close in the topical space to the authors and close in like seniority, that will also increase their chances of being predicted as saying yes. So there are other factors that not only the ones that have reviewed before. But that's an interesting question because there are all of these more complicated decision processes that are actually happening in the invitation process. So this model that I presented is just a one-shot invitation model. So you invite once. But if you expand people with invitations, maybe they won't like that. So there is a temporal component in the invitation process that is not being considered here. So it will be extended in the future as well.
Right, absolutely. I actually had one question of my own that I just was wondering if you had looked at. You mentioned this confidence field, and I wondered how that related to reviewer score. I know there's kind of a limited amount of data, but just based on your initial data set that you got from this conference, did you find that there was a relationship there? For
So
instance?
we did a couple of analyses. So we did an analysis in which we tried to do first the correlation between reviewers. So let's say if they are reviewing, like, let's say we take a paper that had, in this conference was like from 1 to 7. We take papers that had like 6.5. The correlation of the reviewers there was the same as the correlation of reviewers reviewing papers that got like 1. Essentially, that the paper has higher score doesn't mean that reviewers are going to be like agree more on the score. The same thing happened with the confidence. So the better the reviewer, I'm sorry, the higher score of the paper didn't mean that they were more confident in their score. And the correlation, I'm not exactly sure, but it seemed that the correlation between scores and confidence wasn't that strong.
Right. Okay. Okay. That's interesting. Well, there's one more question, just mentioning that it's been previously shown that reviewers tend not to comment on the same things when reviewing the same manuscript. Does your calculation account for this? I presume this means something like accounting for one person looking at the methods while another person is more interested in impact or something like that. I think you were saying that you could add different factors.
Right. Yeah, that's a very good question too. So sometimes, again, just talking about grants, program officers are looking for, they have panelists, right? So these are reviewers that are general. They look at the whole paper, the whole application, and it could be, the whole paper. And then you have ad hoc reviewers that are really expert in one particular area of the paper. So that's something that we're working on, and it's a very, very important aspect of the peer review process, where you have reviewers that are tracking different things. And I think that's something that is very, very neglected. I think we need more of that. We need sets of reviewers that are looking at different things. Someone that is an experimentalist looking at the experiment, another person who is a statistician looking at the statistical test and evidence behind the claims. That I think is very important. Nobody seems to be talking about.
Yeah, agreed. Okay, I think that's all the questions we have. I'd like to thank you very much, Dr. Acuna.
Thank you for the invitation. Yeah.
Yeah, no, that's great. And thank you everyone for joining. Again, I'd like to invite you to visit our website at aibs.org and consider becoming a member. And also, please follow us either at the SPARS website at spars.aibs.org or on Twitter at aibs_SPARS for updates about upcoming webinars and whatnot. And thank you all for your time, and have a great rest of your afternoon. Thanks.
Nice. Bye.